Group 2 elements, alkaline earth metals. Alkaline earth metals. There are 6 chemical elements in column Group 2 of the periodic table. They are Beryllium Be, Magnesium Mg, Calcium Ca, Strontium Sr, Barium Ba, and Radium Ra. These, except beryllium, are known as alkaline earth metals. The element beryllium differs from the rest of the members and shows diagonal relationship to aluminium. They have very similar properties. They are all shiny, silvery white. Because of their reactivity, the alkaline metals are not found free in nature. They are less metallic in character than the group 1 alkali metals. Electronic configuration. These elements have 2 electrons in the s orbital of the valence shell. Their general electronic configuration may be represented as noble gas Ns2. Like alkali metals, the compounds of these elements are also predominantly ionic. Atomic and ionic radii. The atomic and ionic radii increase with increase in atomic number. The radius of an atom is governed by the number of layers of electrons around the nucleus, the attraction the outer electrons feel from the nucleus, ionization enthalpies. The alkaline earth metals have low ionization enthalpies due to fairly large size of the atoms. First ionization energy decreases down the group. It is to be noted that the second ionization enthalpies of the alkaline earth metals are smaller than those of the corresponding alkali metals. Ionization energy is governed by 3 factors: the charge on the nucleus, the amount of screening by the inner electrons, the distance between the outer electrons and the nucleus. The increase in nuclear charge down the group is exactly offset by the increase in the number of inner electrons. Hydration enthalpies. The hydration enthalpies of alkaline earth metal ions decrease with increase in ionic size down the group. The hydration enthalpies of alkaline earth metal ions are larger than those of alkali metal ions. Physical properties. The alkaline earth metals in general are silvery white, lustrous, and relatively soft but harder than the alkali metals. Melting points. Aside from an irregularity at magnesium, the melting point of each element decreases down the group. Boiling points. There is no clear trend in boiling points for the group 2 elements. Because of the low ionization enthalpies, they are strongly electropositive in nature. The electropositive character increases down the group from Be to Ba. Flame test. Leaving magnesium and beryllium, the alkaline earth metals impart characteristic colors to the flame. These flame colors are pale green for barium, bright red for strontium, and orange red for calcium. In flame, the electrons are excited to higher energy levels, and when they drop back to the ground state, energy is emitted in the form of visible light. The electrons in beryllium and magnesium are too strongly bound to get excited by flame. Hence, these elements do not impart any color to the flame. The flame test for Ca, Sr and Ba is helpful in their detection in qualitative analysis. Chemical properties. The alkaline earth metals are less reactive than the alkali metals. Reactivity towards air and water. The alkaline earth metals react with oxygen to produce metal oxides. Powdered beryllium burns brilliantly on ignition in air to produce BeO and Be3N2. Magnesium burns with dazzling brilliance in air to give MgO and Mg3N2. 2Mg solid plus O2 give 2MgO solid. 3Mg solid plus N2 give Mg3N2 solid. Calcium, strontium and barium are readily attacked by air to form the oxide and nitride. They also react with water even in cold to form hydroxides. The larger metals react with water to produce hydrogen gas. M solid plus 2H2O liquid give M2 plus aqueous plus 2OH minus aqueous plus H2 gas, where M is equal to Ca, Sr or Ba. Reactivity towards the halogens. The alkaline earth metals reduce halogens at elevated temperatures to form ionic halides. M solid plus X2 give Mx2 solid, where X is equal to F, Cl, Br or I. BeF2, beryllium fluoride, is prepared by thermal decomposition of NH4 whole 2 BeF4. NH4 whole 2 BeF4 at T degree centigrade give 2NH4F plus BeF2. BeCl2 is prepared from the beryllium oxide. BeO plus C plus Cl2 at 600 to 800 K give BeCl2 plus CO. Reactivity towards hydrogen. All alkaline earth elements except beryllium combine with hydrogen on heating to form their hydrides MH2. Reaction between hydrogen and alkaline earth metals. M solid plus H2 solid give MH2 solid. M can represent Ca, Sr or Ba. BeH2, however, can be prepared by the reaction of BeCl2 with LiAlH4, lithium aluminium hydride. 2BeCl2 plus LiAlH4 give 2BeH2 plus LiCl plus AlCl3. Reactivity towards acids. Each metal reacts with dilute hydrochloric acid, producing hydrogen gas and a colorless solution of the metal chloride. M plus 2HCl give MCl2 plus H2. These reactions become more vigorous down the group. Reducing nature. The alkaline earth metals are strong reducing agents due to large negative values of their reduction potentials. Low negative value of beryllium compared to other alkaline earth metals is due to large hydration energy of Be2+ ion and relatively large value of the atomization enthalpy of this metal. Solutions in liquid ammonia. Like alkali metals, the alkaline earth metals also dissolve in liquid ammonia to give deep blue-black solutions forming ammoniated ions. M plus X plus Y NH3 give M NH3 X whole 2 plus 2 E NH3 Y whole minus. Solutions of alkali metals in liquid ammonia are good conductors of electricity due to the presence of solvated electrons which are not attached to single atoms. Uses. Copper beryllium alloys are applied in hand tools and high-strength springs for industries. Alloys of beryllium and nickel are applied for specialized electrical connections as well as for high-temperature uses. Magnesium aluminium alloys, being light in mass, are used in aircraft construction. Magnesium alloys are also used in baseball catchers' masks, skis, race cars, and even horseshoes. A suspension of magnesium hydroxide in water, called milk of magnesia, is used as antacid in medicine. Magnesium carbonate is used in toothpastes. Calcium in the form of limestone and gypsum has been used as a building material. The steel, glass, paper and metallurgical industries use calcium hydroxide and calcium oxide. The food, cosmetic and pharmaceutical industries use calcium in antacids, toothpaste, chewing gum and vitamins. Calcium is also used in the extraction of metals from their oxides, which are difficult to reduce with carbon. Strontium is used in the making of fireworks, signal flares, and tracer bullets. Barium sulfate is used as a white pigment in paints, while barium carbonate is used in the production of optical glass, ceramics, glazed pottery, and specialty glassware. Radium salts are used in radiotherapy, for example, in the treatment of cancer.